be building a model for you from scratch, as the name of the webinar implies. Not completely from scratch, as I will imply, but here is just the basic user interface of our software. And first things first, I have created a hypothetical demo model that I will be using or building, so to speak. First thing, I will import features from another model. So this helps a lot of time, to save a lot of time, as I will not have to define my drawing states, my colors and sizes for different things, my background layers, my materials and curves, and also patterns. So I will just import some features first. So now I have certain drawing states that I can use to visualize results once I have them. And I also have now a material library, our international set of material libraries. So the pipes that I will be bringing in, I can just define a material for them, and they will be getting their properties from the material library. One other thing that I do want to set immediately is a digital elevation model. I will be using now for this purpose Open Topography DEM, NASA DEM Global. So this is in our latest softwares, we have global digital elevation models that can help a lot when working. Also, you might want to pay attention to CRS, Coordinate Reference System, but I will just be working with the VGS 84 for now. So I will be bringing in just an existing network. Let's imagine that this is already there on ground. What I have to define is the geometry of the pipe so that it comes to the right place. And then I also want to bring in the material so that it gets all of those other properties. If you would be bringing in material from a real existing system, network information system, or GIS, you could use these tolerance values and others to help the material, the pipes, to be actually connected to each other, as there are always problems with this information. But I will now just bring in these pipes, and as we can see, they appeared in the scenic Liechtenstein, in the capital Vaduz. And what I also want to be bringing in is some consumers that exists in the network there. So I will be bringing in some of these, and this would now be consumers. We can also bring it from Excel files from many different types of sources, but these ones already have geometry very nicely, X and Y coordinates. Then I will be giving them their base demand according to each, and a cooling curve and a demand curve, so that they will be behaving according to outside temperature. So I will bring them in, and all of these now, these pink dots here are consumers. What I have to do is I will connect them to the network. So at the moment they are not attached yet, but once I update the demand junctions, they will all be having now this the connection that this is the place where they will be actually taking the energy from the network. But what is now missing in my example network is now the source of energy. And I will be just creating a plant here, a main plant, so that I can get some energy coming into the system that can be then provided to the consumers. And now immediately, when I brought all of these pipes, they received their elevation from the digital elevation model that I have inputted here. So as can be seen, that there are some that are quite a bit higher and some are quite a bit lower geographically. So what I do want to put for my main plant is, let's say that it keeps a fixed return pressure of 2 bars coming back there. And what I will also put is a supply temperature curve, so that it will be following the outside temperature once I get to that point, is when the temperature goes down, it will be putting higher degree water into the system. And this same applies for all of our consumers, as I have put them to follow this type of curve, that once it starts to get colder and colder, they will be scaling up their house warming. And these can be done for as many different types, individual for factories or bigger consumers, but now I'm just using for all of my consumer this one generic. What I then also wish to do is that I will, let's go here. I want to get some outside temperature data. So I'm gonna load the National Oceanic and Atmospheric Administration, and we have one weather station just here in our network. So I'll download some weather data. Let's say 1 year of weather data from the end of March last year, dry bulb temperature up until last midnight. And let's download that. And this will allow us to, something weird going on there, to see what has the outside temperature been in Vaduz. So we can see that -10 has been more or less the minimum that it has reached during the last year. And that is why now these curves are at -10, they reach their fullest potential. So I don't have any results yet, but if I just simulate, then I get some results. Let's see, for example, by using the profile. From here is the main plant, and we are going towards the end there. And we are not experiencing a lot of friction losses, as the heads are not changing that much. What we could do is create another child scenario in which we define that, okay, in this scenario, I want the outside temperature to be -10. So I didn't put the pressure difference setting here, is what we want to be doing, only keeping, let's say, 2 bars of pressure difference at the main plant. We could also define a control node so that this main plant is looking at some point in the network that it would then be keeping the pressure difference setting at. But now it's keeping 2 bars here at the main plant itself, and there's some slight friction losses happening, but my pressure differences are quite nice. It's between 0.5 and 1 bars in here, and not a lot of problems are existing with this small type of setting. Obviously, it is not very optimal, and it's not everything is looked until the end. But as I want to go forward, what would then be the case if I would create a new scenario where I will be bringing in a new network? So it remembers my selection of geom and the material, so I can just bring these in. And now I have a quite a bit bigger network that was added to this. And of course, again, now we only have consumers here, so we should be bringing in some consumers also that we might be expecting to have there. So possible future consumers into our network to understand, could this network function the way that it is? Let's import those. And now we have quite a bit more consumers here again. Let's again update the demand junction so that they are actually connected there to the network. And we can just go ahead and then simulate to see how would the network function. So I run run into quite some troubles as the pressure difference becomes very minimal here, and there's a lot of power deficit that's happening. So power that is not being able to brought into those consumers. But what is actually happening here is that when I brought in my pipes, I forgot to check if it was properly connected. So this is always the case when you're bringing in new pipes. You want to make sure that the topography is well and good. So in here, there is no pipe connection. Once I fix that, I am rather sure that this should also be the way that it functions, and I can achieve quite a bit better results in my system once the flow can also go through here. What might still be some problems that my network is now experiencing? This area here is extremely high, and if we look at supply pressures, and this, yes, let's look at let's keep, for example, 2 bars at the main plant, and what would be the profile when going to this high location? It is just going on a bit of a mountain there, so obviously our pressures are not sufficient to supply here. What we would have to do is then create a new pressure zone that I can, for example, I'll split this pipe and I will make this into a pump battery. So this pump battery will now be pumping supply water into here. And if I close this, I have a new pressure zone here, which is the highest elevation area. And then this will, so there's quite a bit of problems there. I have a solution for that also that we will go into once we fix just this. I'm just increasing the pressure difference setting here so that more pressure difference is allowed to be had at the main plant. But now the water that I'm pumping is supply water. I want to keep, let's say, 1.5 bars. Let's keep the 1.5 bars pressure difference setting at a control node. And I will select this point to be my control node. So I just select the junction and at the control node here with the right click. And now this one will be watching the pressures of this junction here and keeping 1.5 bars of pressure difference there. And then I have to create a valve that the return water can find its way back here. And I will, sorry, not loss coefficient, but I will keep 4 bars of pressure braking. So if we look at this profile, now that I have created the valve also, and the pump will be keeping 1.5 bars of pressure difference here. Once I simulate this model again, we will be able to see that with the use of this pump, and now the valve will be decreasing the return pressure, we can be sure that we are not having any problems with the ground elevation, and enough pressure is both on the supply and return side over here especially. So now we have fixed some issues that are here, but some issues are still really here in the north side that we can see. We could of course always increase the pressure difference setting of our main plant, but that might not be ideal to constantly always just be increasing. Luckily, what we have is we have a new, let's say, biomass plant in the north. So I create another child scenario where I have just received information that this place here, there is a good place to set up a plant, as the pipes are also quite big. that are going in that direction. And there would be opportunity here to produce power. So I will just set a plant with a constant power of 15 megawatts. And I'll give it a power curve so that it will also be dependent on the outside temperature that I will now do next here. So it will now be pushing in some extra energy into the model, and I'm sure that it will help a lot our system to function. So just a small schematic, which is the tool where we can, for example, compare a couple of different scenarios to each other. So this one, I will make it show the future plant network where we are having a lot of troubles with the pressure differences. But in this one, which is the new biomass plant in North, we are not really having too many problems. If I change these different visualizations, I can see the differences there, that what's going on in both of these networks, and compare them just visually easily. This schematics tool allows us to do very comprehensive comparisons between these different scenarios, but for this webinar purpose, I will just be showing these couple of different pictures this way. But perhaps there would be another solution also. So what if instead of building a new plant here, because this was the future plant network, what if we would just increase the pipe sizes of this main line here that we brought? So let's check, could that solve this possible problem that would arise? So I will change scenario and mass select two components, and I can just get all the components between them, and with mass selection, change all of these pipes into 250 inner or nominal diameter. So the diameter is now 263. Let's simulate the model again and see if we have managed to solve most of our problems. So actually, with this increasing the pipe sizes, I will just deselect these close demand so they are not confusing there in this visualization. By increasing these pipe sizes here that would be built, we would be able to solve a lot of our other problems that were arising because we could not provide enough water for our consumers, enough energy. So that was a couple of different things that now we have just, let's again make this the time series that I brought. So now that we have brought in this type and we have put all of our components to be outside air dependent. So if we would, for example, this where we changed the, let's just create it here. So January 2022 simulated. So I would select here that instead of some specific outside air temperature, it will now be following the outside air temperature of this time series here. And once I tell it that, okay, I want you to be modeling from the beginning of January until the end of January, and I will give it a couple of days time to just balance itself. And I will model now 1 month worth of simulation. And as we can see, it is quite fast. And we should be getting the results any second now. So here on the results that we will be getting just now, we will be able to see the air temperature of this particular scenario. Great, now we finally have. So the air temperature is changing throughout January. It goes quite high at the beginning of January, then it starts to go quite low, and then it varies constantly. And how our main plant, how our network would be functioning in this exact conditions would be that we are creating less energy, we are putting more energy into the system, and obviously the flows would be quite a bit changing also, and the supply temperature that now we said that you should be following the air temperature, so it is exactly doing that. We are having quite some problems here, so the new biomass plant in the north might be quite a good choice for this hypothetical Liechtenstein model. But for now, I think this was just a quick glance at some of model building in Fluidit Heat and understanding some drawing states, base scenario usage, and importing materials. So I hope that this was informative, and I believe if there are some questions, perhaps we can go through a couple of those.